Hello everyone, welcome back to my channel Gems of Knowledge. So I'm here with another video on the statistics, that is exercise 14.3, that is the continuation part of exercise 14.3. So I hope you have completely watched all the three questions of this exercise earlier. Okay, if you have not watched with that video, I will link it into the description box or on the somewhere on the screen, that is on the I button, so you can click it and you can watch it later. So you know the drill. Before starting this video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new video. So this is the next question, that is fourth one. The length of 40 leaves of a plant are measured correct to 1 millimeter. Okay, this is the length of the 40 leaves of a plant and obtained is represented in the following table. So the length, so there are three leaves which is having the length 118 to 126, then five leaves between 127 to 135, 136 to 144 there are nine leaves, 145 to 153 there are 12 leaves, and 140 154 to 162 there is five leaves and so on. Okay, so what we need to do here is, the first question is draw a histogram to represent the data. Okay, and one more hint they have given us, that is make the class interval continuous. So here you can see 118 to 126 is given, then 127 to 135 is given. So you all know that for the histogram we don't get any gaps in between. If we get any gaps in between, then definitely it is not a histogram, it is a bar graph. Okay, so for that reason what we need to do is we need to change the length of these leaves. So what we will do is we will make this as continuous. So how can we do that? What we need to do here is, from here we need to add 0.5. Okay, and from here we need to subtract 0.5. Okay, so from the right side we will add it, and from the left side we will try to remove 0.5%. So okay, so 0.5 if we remove from here, we are left with 117.5. Okay, and if we add over here we will get 126.5. Okay, then the same thing here also, if we remove out we will get 126.5, and if we add here 135.5. Similarly here also 136 minus 0.5 is 135.5, here to 144.5. Okay, then here 144.5 to 153.5, then again here 153.5 to 162.5, again 162.5 to 171.5, and 171.5 to 180.5. Now you can see here the new continuous interval what we got here is repeated. Okay, repeated in the sense continuous we can say. Okay, there is no point in between where there is gap. So here there was a gap from 126 to 127, there is no no length of leaves. So what we can do there, 126 to 127 we have to leave the gap, which is not possible in present in the case of histogram. Okay, so now depending on this length we are going to draw the histogram. Okay, so as you all know, this is ready over here. So 117.5 to 126 we are having three leaves. Okay, so three leaves means it will come between 2 to 4, that is somewhere here. Okay, so from here to here. Okay, so we need to join this. Okay, then in the next case you can see there they have given 126.5 to 135.5. Okay, so 126 to 135 we are having how much, 5 leaves. So from here 5 comes between 4 and 6. Okay, so 5 comes over here, so this is 5 leaves. Okay, Then again between 135 to 144.5 we need 9 leaves. 9 comes between 8 and 10. So it will be somewhere here. Okay. So this is done. Next 144 to 153.5 there is 12 leaves. So 12 comes here. As you can see 12 is here. Okay. So this is 12 leaves. Okay. Next 153 to 162 we are having 5 leaves again. 5 comes somewhere in between 4 to 6. So 5 is here. Okay, so this is 5 leaves. Then it comes 4 leaves. Okay, then we are getting 4 leaves from here. So from here to here we are getting 4 leaves. Okay, then again actually I needed one more thing here, so let me do it here as I am not having the graph sheet over here. So 171 to 180.5 this is okay, this point is 180. So 171 to 180 I'm having 2. So somewhere here we are going to get, and let me join it like this. Okay, so this is the histogram which we needed. So we will write here x-axis is equals to 1 centimeter. So 1 centimeter is not here, so what we have taken here is 2 centimeter gaps. So what we will write here is 2 centimeter is equals to, if we subtract this 2, that is 126.5 minus 117.5, what we are going to get is 5 minus 5 is 0. 6 minus 7 is not possible, so 16 we will take. 16 minus 7 is 9. Okay, and this is 1 here. 1 minus 1 is 0. This is also 0, so we are getting 9 over here. So 2 centimeter is equals to 9. So what is this actually we have taken? 9. See here, what is this we have taken? This is length in mm. Okay, so 9 mm we have to write length. Okay, then y-axis also 1 centimeter only we have taken, but 2 unit. What is this actually? This is nothing but number of leaves. So what we will do here is 2 leaves. So number is 2, so 2 leaves. Okay, so here you need to write it. Okay, that is length in mm you need to write here. Okay, and here you need to write number of leaves. Okay, this way you need to write this. Okay, this complete the part of histogram. So there is one more question: is there any other suitable graphical representation for the same data? Yes, there is another graphical representation that is known as frequency polygon. So this is also the method which can be done. Okay, this method can be done for the frequency polygon also. Okay, is it correct to conclude that maximum number of leaves are 153 long? Okay, so we need to find out whether is it correct if we tell that maximum number of leaves are 153 long. Okay, as you can see here the range, you can see here the highest range here is the leaves are lying between 144.4 to point 0.5, sorry, this is 0.5, 144.5 to 153.5. So directly the leaves which are longest or which is having the maximum leaves, that is between this length. Okay, so directly we cannot say that all the leaves are 153.5 only, because we got that in between this length, that is there are 12 leaves in between this, that is 144.5 to 153. They may be 149 also, they may be 150 also, they may be 152, they may be 153. So directly we cannot conclude that all the 12 leaves are 153.5 only. So what we will write here is maximum leaves lies No, we will write, is it correct to conclude, they're asking. So no, we will write, because maximum number of leaves okay lies between the interval 144.5 to 153.5. Okay, so this answer is done. We'll move on to the next. Okay, so the next question is given. The following table gives us lifetimes of 400 neon lamps. Lifetime in hours, they have given 400 neon lamps. So there are 400 neon lamps. So between the 300 to 400 hours, there are 14 lamps. 400 to 556 and 500 to 660 and so on they have given. Okay, so we need to represent the given information with the help of histogram. So we need to draw a histogram over here. Okay, so the format is ready over here and we need to draw a histogram. Okay, so between 300 to 400 range, how many are there? 14 are there. Okay, so on x-axis what we have taken is lifetime we have taken. So here you need to write this is lifetime, and here what we have taken is number of lamps on the y-axis. Okay, so this is number of lamps. So between 300 to 400 there are 14 lamps. So 14 in the sense this is 10. Okay, next line is 11, 12, 13, 14. So first one will be here. Okay, next comes 400 to 500. Between 400 to 500 it is 56. So directly 55 and 56, this is 56. Okay, then 500 to 600 is 60. Okay, then 500 to 600 is 60. Okay, then 600 to 700 they have given 86. 86 in the sense this is 80 as you can see. Okay, and this is 85 and 86, it is somewhere here, this is 86. Okay, then next as you can see here 700 to 800 is 74. So 74, this is 70 and next 4. Okay, so this is the next 4, 74. Okay, then 800 to 900 it is 62 given. 62 in the sense this is 60 and 2 lines above, that is 62 is here. Okay, this is 62. Then comes 900 to 1000 is 48. Okay, so 900 to 1000 is 48. So this is 40, this is 45, 46, 47, 48 here. Okay, so this is 48. So last we need to write the scale over here. Scale is equals to 1 cm, x-axis is equals to 1 centimeter is equals to 100 hours. Okay, so they have given as you can see x-axis is 100, the difference between this is 100. Okay, so 1 centimeter is equals to 100 hours. Again you can see y-axis is equals to 1 centimeter is equals to, as you can see 1 centimeter is equals to, the difference here is 10 lamps. Okay, so here the difference is 10 lamps. Okay, so the difference between this question and the previous question is, here you can see the whatever they have given the lifetime of the lamp, this is continuous. So 300 to 400, then again 400 to 500. In the previous case what we have done is it was not continuous and we had made it to be continuous. Okay, there was some gap in between and we made it to be continuous, but this is continuous. We can directly draw the histogram over this. Okay, so the next one more question they have asked here, how many lamps have a lifetime more than 700 hours? So you can see over here only. Okay, so more than 700 hours in the sense 700 to 800, 800 to 900, 900 to 1000, everything comes. So what we need to do here is we need to add this, that is lifetime of more than 700 lamps, more than 700 lamps are 74 plus 62 plus 48. So what is the total here? 8, 9, 10, 11, 12, 13, 14, 4 and 1 carries, 7, 7 to the 14, 15, 16, 17, 18. So this is 184 lamps. So there are 184 lamps which is having the lifetime more than 700 hours. Okay, we'll continue to the next question. Okay, so the next question, as you can see, the following table gives the distribution of students of two sections according to the marks obtained by them. So section A and section B, these are the students distribution of students in the two sections, and they have given the mark obtained by those students. Okay, so for section A, marks are this: 0 to 10 marks is scored by 3 students, then 10 to 20 9 students, 20 to 30 17 students, 30 to 40 12 students, and 40 to 50 9 students. Similarly here, 0 to 10 5 students, 10 to 20 19 students, 20 to 30 15 students, 30 to 40 10 students, and 40 to 50 only 1 student. Okay, represent the marks of the student of both the sections of the on the same graph by two frequency polygon. So here you need to draw a frequency polygon. From the two polygons, compare the performance of the two sections. We need to compare the performance of the two sections. Okay, so the graph is a bit ready over here. Okay, so according to the section A, we'll go to the section A first over. Okay, so 0 to 10. So we can take 0 to 10. There are 3 students. Okay, so 0 to 10 there are 3 students. Okay, to mark a frequency polygon, what we need to check here is, see here, 0 to 10 we are having. Okay, so there are 3 students, 3 students, in the sense we are marking the frequency polygon, so we will mark this in the center of this. Okay, between 0 to 10 we will mark it on the center. Okay, then 10 to 20, next you can see 10 to 20 there are how many students? 9 students, as you can see over here. 10 to 20 there are 9 students, and again that can be marked 10 to 20. Between 10 to 20 there are 9 students. Okay, so 9 comes between 8 and 10, so this is 9 students. Okay, between, see, between 10 to 20, that is on 15 we are going to mark. Then 20 to 30, 20 to 30 we are having 17 students, so this is also marked in between on 25. How many students? That is 17 students. Then 30 to 40 we are having 12 students, so that 12 will be marked in between this line, that is here, that is 12 students. Then 40 to 50 we are having 9 students, so 9 is also marked on 45, that is here. Okay, now what we need to do here is we will draw a graph over here. Okay, graph in the sense we need to join this lines. So this is the first point, then comes this second point. Okay, then this third point, and then this point. Okay, this is section A. Okay, then we need to show the next section, that is section B. Again from 0 to 10 we will mark it on 0 to 10. Between 0 to 10 we will mark it on 5. Okay, we are having 5, so this is the next point, 5. Then 10 to 20 we are having 19, so 10 to 20 we need 19, and we will mark it on 15. Okay, so 19 will be here. Okay, this is 19, as you can see. Then again 20 to 30, this part 20 to 30 we are having 15. 15 comes here. Okay, that is on 25, between these two numbers. Okay, then again 30 to 40, again on the between number 30 to 40 we need 10, so it is here. Then again 40 to 50, it is 1. 1 comes here. Okay, between 0 to 2, 1 comes, that is here. Okay, now again we will join these points. Now again we will join these points. This is for the section B, first point. This is second point, then again a little bend, this is third point, and this is fourth point. This is section B. Okay, so this is section B. So this is the polygon which we need to draw here, comparing the results of the students. Okay, marks distribution of the students, we can see that section B is having the more number of marks. As you can see, it is having the peak over here. Okay, so that's what we can compare the performance over here. Okay, between 5 to you can see between 0 to 10 the performance is bit higher in section B. Again 10 to 20, obviously section B is higher. Again 20 to 30, there is a performance low into the section B. Then 30 to 40 again lower, and 40 to 50 again lower. Okay, so the performance is, we can say, in the starting it is higher, and the less then it is very less. Okay, so I hope we are clear with this video. So I'll be back soon with the continuation part of this video. So till then, don't forget to like, share and subscribe. I'll be back with that video. So till then, stay tuned and stay connected. Thank you.